Now we're going to have a look at the scan function, so the list.scan function in F#, which allows us to do the same thing that we can do with the fold function, but we also get the intermediary results. So if you haven't seen the fold function before, I've done a previous video on that, so please check it out. But the scan function does something very similar, only that it gives us the intermediate values. So I'm going to create an example here that we can follow, and so that you can see how the implementation works. For this, we're going to need a type. I'm going to call it charge, like this, and it's going to have either a positive or a negative value. So we would create positive of int like this, or a negative value, and that's also going to be an int like that. My idea here is we're going to have a list of inputs that are going to be charges, either positive or negative, and we want to aggregate those and see sort of what the aggregation does over time. That's what scan is really useful for. So let inputs, we're going to say that this is a list like that, and we're going to create a positive value first. Let's give it a value of 1, then we're going to make a negative value of 2, and lastly another positive value of 3, like that. So we have 3 charges. We want to aggregate them and get a final output. What we can do is we can create a aggregate charge function, and we're going to do that now. So this will allow us to look at what the sum is at one point in time and then add another charge to that, and so accumulate, as we go across this list. So aggregate charge, and then it's going to take 2 input arguments, the current sum being the first one, and then new value being the second one. And we would simply say match new value with, and then we would say either this is a positive value, p, and in that case we will take sum plus p, or it's a negative value, n, and in that case we would subtract from the sum, so sum minus n. Now, of course, if we just represented our charges as integers that could be either positive or negative, we wouldn't have a need for all this fancy manipulation. But thinking about this from a wider context of a general application in a system, you might discriminate between different types of values and you want to aggregate them in some way. So this is just a toy example. But nevertheless, given that we have this function that allows us to sum our charges, whatever they might be, we can now create a myScan object. So I'm just going to name a variable myScan, and this is going to take an initial value of 0 and the inputs list, and we're going to send that we're going to send that to the list.scan function, and we're going to give it the aggregate charge as an input argument. And if we execute all this, let's see what we get. Okay, so you can see that the output here is 0, 1, minus 1, 2. And the reason why we get that is we give an initial value here, which I gave it to be 0, and then we give it the input array that it's supposed to scan. What it does is it applies the aggregate function to all of these elements, starting from the left and making its way to the right. So we begin with the initial value of 0, and we simply put that in the list because, well, that is our starting point. That's the initial value variable. What we do then is this goes into our aggregate charge function as the sum argument here. And the first value of our list is going to come in as the new value. So the first value that we get in as the new value is going to be 1 because our first element here is a positive 1. So we add that to 0 and we get back a sum of 1. Now, once we have this, that's going to be the sum value that we send back into our aggregate charge. And the new value we send in is going to be this one, negative 2. So since we had 1 before, we subtract 2 from that, we get minus 1 as the next output. And then with the third application, positive 3 coming in, if we take minus 1 plus 3, then we get a value of 2. So this simply applies the aggregation function to the entire list, starting from the starting value that we provide here, and then gives us back the list. Now, you might be familiar with this logic. This is in fact the same logic that we get if we apply something very similar, namely the fold operation. So if I just send or create my fold here and use the fold function rather than the scan one and execute this, you can see that the output here, the final output 2, is the same one as our final output in the list. And in fact, they get applied in exactly the same way, the scan and fold functions. The only difference between them is that the scan one gives you the entire history of values, whereas the fold one just gives you the final output. So that's the list.scan functionality. I hope you like this video, and I'll see you in the next one.